Hey everyone, welcome back. In earlier videos, we've talked about what version control is, why it's necessary. We also started learning some basic Git commands and procedures. Now we'll go into much more detail about what we can do with Git. These are Git's greatest hits. We'll start by learning some handy shortcuts and looking into how we can get more info out of our version control system. Then, we'll experience the true power of Git by seeing how we can undo some of our changes, and many different techniques that we can use in Git. Let's start with the following command. Git commit-a is a shortcut to stage any changes to track files and commit them in one step. But if the modified file has never been committed to the repository, we'll still need to use git add to track it first. So let's make a change to our example script from the earlier video and try out this new flag. We'll now modify our main function and make it call the check reboot function that we wrote before. If a reboot is pending, we'll print a message and then exit our program with an exit status of 1. Since we're using the sys module, we'll need to import it. Alright, now that we've made the change, we're ready to try out the new -a flag. We'll also use the -m flag to add the commit message directly. This time, we'll say that we're calling check_reboot and exiting with 1 on the error condition. These shortcuts are useful when making small changes that we know we'll want to commit directly without keeping them in the staging area and having to write long and complex descriptions. Keep in mind that when you use the -m shortcut, you can only write short messages. So it's best reserved for truly small changes that don't require extra context or explanation, short and sweet. Heads up, when you use the -a shortcut, you skip the staging area, meaning you can't add any other changes before creating the commit. The commit will show up in the log along with the message, just as usual. Let's check that out with git log command. See how our latest commit was added to the top of the list of commits, and notice how the head indicator has now moved to the latest commit. You might be wondering, what is this head and where is it heading? Git uses the head alias to represent the currently checked out snapshot of your project. This lets you know what the contents of your working directory should be. In this case, the current snapshot is the latest commit in the project. We can even use Git to go back in time and have head representing old commit from before the latest changes were applied. In all cases, head is used to indicate what the currently checked out snapshot is. This is how Git marks your place in the project. Think about it as a bookmark that you can use to keep track of where you are. As a shortcut, it's generally easy to think of head as a pointer to the current branch, although it can be more powerful than that. Next, we'll dig into how we can get more information about our changes, both before and after we commit them. We've seen how git log shows us the list of commits made in the current Git repository. By default, it prints the commit message, the author, and the date of the change. This is useful, but if we're combing through a history of changes in a repo to try and find what caused the latest outage, we'll probably also need to look at the actual lines that changed in each commit. To do this with git log, we can use the -p flag. The P comes from patch, because using this flag gives us the patch that was created. Let's try it out. It shows added lines with pluses and remove lines with dashes. Because the amount of text is now longer than what fits on your screen, Git automatically uses a paging tool that allows us to scroll using page up, page down, and the arrow keys. We still have one commit below the other, but now each commit takes up a different amount of space depending on how many lines were added or removed in that commit. Using this option, we can quickly see what changes were made to the files in our repository. This could be especially useful if we're trying to track down a change that recently broke our tools. If we don't want to scroll down until we find the commit that we're actually interested in, another option is to use the git show command. This command takes a commit ID as a parameter and will display the information about the commit and the associated patch. Remember that this is an identifier that we see next to the word commit in the log. Let's check this out by first listing the current commits in the repo and then calling git show for the second commit in the list. Another interesting flag for git log is the -- stat flag. This will cause git log to show some stats about the changes in the commit, like which files were changed and how many lines were added or removed. Let's try it with our repo. Now, what about changes that haven't been committed yet? Until now, whenever we've made changes to our files, we've either added them to the staging area with git add and committed them with git commit, or committed them directly using git commit -a. This works fine, but it means we have to know exactly which changes we've made. Sometimes it can take a while until we're ready to commit. But imagine you've been working on adding a new complex feature to a script and it requires thorough testing. Before committing it, you need to make sure that it works correctly. Check that all the test cases are covered and so on and so on. So while doing this, you find bugs in your code that you need to fix. It's only natural that by the time you get to the commit step, you don't really remember everything you changed. To help us keep track, Git gives us the git diff command. Let's make a new change to our script and then try this command out. We'll add another message to the user to say that everything is okay when the check is successful and then exit with 0 instead of 1. Okay, we've made the change. Let's now save it and check out what git diff command shows us. In this case, we see that the only change is the extra lines that we've added. If our change was bigger and included several files, we could pass a file by parameter to see the differences relevant to that specific file instead of all the files at the same time. Something else we can do to review changes before adding them is to use the -p flag with the git add command. When we use this flag, Git will show us the change being added and ask us if we want to stage it or not. This way we can detect if there's any changes that we don't want to commit. Let's try that one out. We've staged our change, and it's now ready to be committed. If we call git diff again, it won't show any differences since git diff shows only unstaged changes by default. Instead, we can call git diff -- stage to see the changes that are staged but not committed. With this command, we can see the actual stage changes before we call git commit. Let's commit these changes now so that they aren't pending anymore. We'll say that we've added a message when everything's okay. Nice. And with that, we've learned a bunch of different ways to get more information about our changes. Let's say that you've decided to clean up some old scripts and want to remove them from your repository. You can remove files from your repository with the git rm command, which will stop the file from being tracked by Git and remove it from the Git directory. So you'll need to write a commit message as to why you've deleted them. Let's try this out in our checks repository that contains a file we decided we actually don't want. We'll first look at the contents of the directory with ls, then delete the file with git rm, then check the contents with ls again, and finally check the status with git status. Let's do that now by calling git commit and setting a message indicating that we've deleted the unneeded file. As usual, we get a bunch of stats when we do the commit. Check out all the deletions it reported. These are all lines in the file that are no longer there, and it states the file itself was deleted. You can use the git mv command to rename files in the repository. Let's rename our existing script to checkfreespace.py, and then check what git status has to say about that. The status shows us that the file was renamed and clearly displays the old and new names. As with the previous example, the change is staged but not committed. Let's commit it by calling git commit once again. The mv command can be used for both moving and renaming. If our repository included more directories in it, we could use the same git mv command to move files between directories. The output of git status is a super useful tool to help us know what's up with our files. It shows us which files have tracked or untracked changes, and which files were added, modified, deleted, or renamed. It's important that the output of these commands stays relevant to what we're doing. If we have a long list of untracked files, we might lose an important change in the noise. If there are files that get automatically generated by our scripts, or our operating system generates artifacts that we don't want in our repo, we'll want to ignore them so that they don't add noise to the output of git status. To do this, we can use the git ignore file. Inside this file, we'll specify rules to tell Git which files to skip for the current repo. For example, if we're working on an OS X computer, we'll probably want to ignore the .ds store file, which is automatically generated by the operating system. To do this, we'll create a .gitignore file containing the name of this file. Remember that the dot prefix in a Unix-like file system indicates that the file or directory is hidden and won't show up when you do the normal directory listing. That's why we have to use ls-l to see all files. We've added a gitignore file to our repo, but we haven't committed it yet. This file needs to get tracked, just like the rest of the files in the repo. Let's add it now. Done, and it looks great. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we will learn how to undo things with Git. Thanks for watching, and see you soon.